Hello, and welcome to Dr. Carminati's channel, where we dive into the intricate worlds of artificial intelligence, cybersecurity, and quantum computing. I'm thrilled to have you with us today as we explore a groundbreaking development that's poised to reshape modern warfare: the Pentagon's ambitious Replicator program, designed to deploy millions of autonomous flying drones. Before we dive in, I encourage you to share your thoughts in the comments below. Like this video if you find it informative, and subscribe to stay updated with our latest discussions. Imagine a battlefield where swarms of drones operate in unison, executing missions with precision and minimal human intervention. This isn't a scene from a science fiction movie. It's the vision behind the Pentagon's Replicator program. Announced recently, this initiative aims to mass-produce autonomous flying drones, enhancing the United States military capabilities and maintaining a strategic edge over global adversaries. The Replicator program is a response to the evolving nature of warfare. Rapid technological advancements are redefined traditional combat strategies, and unmanned systems are at the forefront of this transformation. These drones are not merely remote-controlled devices. They are equipped with sophisticated artificial intelligence, enabling them to make real-time decisions, adapt to dynamic environments, and execute complex missions without direct human oversight. One of the driving forces behind this program is the need for scalability and rapid deployment. In potential conflict scenarios, especially those involving near-peer adversaries, the ability to quickly deploy a vast number of assets can be a decisive factor. The Replicator program envisions the production of drones on an unprecedented scale, ensuring that the military can respond swiftly to emerging threats. However, the deployment of such a massive fleet of autonomous drones raises several critical considerations. First and foremost is the question of control and decision-making. While these drones are designed to operate autonomously, it's imperative to establish robust frameworks that govern their actions, ensuring compliance with international laws and ethical standards. The integration of human oversight mechanisms is essential to prevent unintended escalations and ensure accountability. Cybersecurity is another paramount concern. As these drones rely heavily on interconnected networks and AI algorithms, they become potential targets for cyber attacks. Ensuring the resilience of communication channels and the integrity of onboard systems is crucial to prevent adversaries from compromising or commandeering these assets. This necessitates continuous advancements in encryption, intrusion detection, and system hardening techniques. Logistics and maintenance also present significant challenges. Efficient supply chains, maintenance protocols, and personnel training programs must complement the mass production of drones. This includes the development of modular designs that facilitate easy repairs and upgrades, as well as the establishment of infrastructure to support large-scale operations in diverse environments. The Replicator program also has profound implications for the defense industry. Traditional defense contractors may need to adapt to new production paradigms that emphasize speed, flexibility, and cost-effectiveness. This could lead to increased collaboration with tech companies specializing in AI, robotics, and manufacturing, fostering innovation and the cross-pollination of ideas. From a strategic standpoint, the integration of autonomous drones into military operations offers several advantages. They can undertake high-risk missions without endangering human lives, provide persistent surveillance over vast areas, and overwhelm adversary defenses through sheer numbers and coordinated tactics. This shifts the operational landscape, compelling adversaries to develop new countermeasures and strategies. However, this technological leap also prompts a re-evaluation of existing doctrines and rules of engagement. The speed and autonomy of drone operations may outpace traditional decision-making processes, necessitating the development of new command structures and protocols. Additionally, the psychological impact on both operators and adversaries must be considered as the nature of combat becomes increasingly impersonal and machine-driven. Internationally, the Replicator program is likely to influence global military dynamics. Allies may seek to develop compatible systems to enhance interoperability, while potential adversaries might accelerate their own autonomous weapons programs in response. This could lead to an arms race in unmanned systems, underscoring the need for international dialogues on regulations, norms, and the prevention of unintended escalations. Ethically, the deployment of autonomous drones raises questions about accountability in combat. Determining responsibility for actions taken by AI-driven systems is complex, especially in scenarios where machines must make split-second decisions. Establishing clear guidelines and ensuring transparency in the development and deployment of these systems is essential to maintain public trust and uphold moral standards. the psychological impact of drone warfare extends beyond the battlefield. For operators, there is the potential for increased cognitive dissonance due to the remote nature of their actions. Unlike traditional combatants, drone operators may struggle with the disconnect between their decisions and their consequences, leading to unique psychological challenges. For adversaries and civilian populations, the persistent presence of autonomous drones can induce fear and anxiety, altering social dynamics in conflict zones. The technological foundation of the Replicator program also warrants attention. These drones rely on a combination of advanced sensors, machine learning algorithms, and secure communication networks to perform their tasks. Sensor fusion, which integrates data from multiple sources to create a coherent understanding of the environment, is critical for navigation and target identification. Machine learning algorithms enable adaptive behavior, allowing drones to respond to unforeseen challenges and optimize their performance over time. However, the complexity of these systems introduces vulnerabilities. Adversaries may attempt to disrupt operations through electronic warfare tactics, such as GPS jamming and signal spoofing. Protecting these systems requires a multi-layered approach, incorporating redundant navigation methods, robust encryption protocols, and real-time anomaly detection. The development of this program also intersects with broader societal and policy considerations. Autonomous weapon systems challenge existing legal frameworks, such as the Geneva Conventions, which were established long before the advent of AI-driven warfare. Policymakers must engage with international partners to develop updated norms and agreements that address the unique characteristics of autonomous systems. Public perception is another critical factor. As with any military technology, the acceptance and support of autonomous drones depend on transparency, oversight, and demonstrated adherence to ethical principles. Engaging the public through educational initiatives, open discussions, and clear communication about safeguards can foster understanding and trust. Looking ahead, the success of the Replicator program will depend on sustained collaboration between government agencies, industry partners, and academic institutions. Innovations in AI, robotics, and manufacturing must be continuously integrated to maintain technological superiority. Simultaneously, ethical considerations and regulatory frameworks must evolve in tandem to ensure responsible development and deployment. In conclusion, the Pentagon's Replicator program represents a significant stride into the future of warfare, leveraging autonomous drone technology to enhance military capabilities. While it offers numerous strategic advantages, it also presents a host of challenges spanning ethics, cybersecurity, logistics, and international relations. As this program progresses, it will be crucial to address these issues comprehensively, ensuring that the integration of autonomous systems into military operations is conducted responsibly and effectively. Thank you for joining me in this exploration of the Replicator program. I look forward to hearing your insights and engaging in thoughtful discussions. Don't forget to like this video, share your comments below, and subscribe to stay informed about the latest developments in AI, cybersecurity, and quantum computing.